For question 4, the resistance R to the motion of a car varies partly as the weight W and partly varies as the square of the speed V. When a car of weight 500 N, that is Newton, is moving at 60 kilometers per hour, the resistance is 1330 N. And another weight 400 Newton, that is N, moving at 20 kilometers per hour, the resistance is 320 N. The question wants us to find A, an expression for R in terms of W and V, and for the B, the resistance to the motion of a car weight 450 N moving at 40 kilometers per hour. For the C, the different question on its own, and that is a number basis question. That is, the question wants us to solve for x if 133 base x is equal to 43 base 7. So we'll go through all the questions, that is the A and B and then the C. So we start with the A. Now the question is saying that the resistance R to the motion of a car varies partly, the key word there is partly, as the weight W and partly varies as the square of the speed V. This is a partial variation question. And how do we solve partial variation question? The first thing we have to do is we need to get the main verbs involved. Now the main verbs are, we have our R, we have our W, and we have our V. These are the three main verbs. But if you read the question, it says that R, that is R, partly, R varies partly, so R varies partly as the weight, and so you bring your plus, partly varies as the square of the speed V. So in this case, we are going to have the square of V, that is V squared. Don't forget, always under partial variation, the end here implies addition. That is why we are having the addition here. So as it stands like this, when you want to change this to the variation equation, you are going to introduce your constant of proportionality or your constant of variation. So you are going to have your R to be equal to, you have your KW plus your K1 V squared, where your K and K1 are constant for you to find. So now we are going to have our equation to be R being equal to, we have our KW plus K1, we have V squared. This is our main equation, so we can label this as, let's say, equation A, or you can number that. So we have our equation A. Now how do we get the value for these constants of proportionalities? That is the K and then the K1. If we go back to the question, it says that when a car of weight 500, so in this case our W is 500, moving at 60 kilometers per hour, so in this case our V has also been given. The resistance is 1330 and R has been given. So what we are going to do is, here you have your W here, you have your V, and you have your R. You are going to substitute this into the equation A, and that will help you to get one equation. So now when we have R to be equal to 1330, we have W to be equal to 500, and we have our V to be equal to 60 from the question. Alright, so this is going to help you to get your first equation. So you are going to substitute these values into the equation A. So we are having our 1330 being equal to, so we have our K multiplying the W, and the W is 500, plus our K1 V squared, and the V is 60, so 60 squared. We try simplifying this further, and this will give us 1330 being equal to 500K plus 3600 K1. So this becomes our equation 1, and we can even reduce this equation because there is a common factor, so we can even reduce that by 10 or divide through by 10. So we divide the side by 10, we divide the side by 10, we divide the side by 10. So we are going to get 1330, sorry, we're going to get 133 being equal to 50K plus 360K1. So this becomes our equation 1. Let's go back to the question again. It says, and another weight. So in this case, our W is 400, our V is 20, and our R is 320 because the resistance is 320. So once again, we are going to take these values and substitute them into equation A, and that will give us our second equation. This is our equation A. So whatever that we see R, we substitute the 320 there. Where we see the W, we substitute the 400 there, and where we see the V, we substitute the 20 there. Okay, so in this case, when R is equal to 320, W is equal to 400, and V is equal to 20. Let's substitute these values into equation A. So that is going to give us, we have 320 being equal to 400 K plus we have a K1 20 squared, and this will give us 320 being equal to 400K plus 400 k1, because when you square the 20, we are going to get 400. And once again, we can reduce this equation. You can maintain that, but the choice is yours. But the most important thing is trying to solve the two equations simultaneously. So I want to reduce this equation. So I'm going to divide through by 80, because I realize that yes, 80 is common there. I can do that. So I divide this side by 80, and divide this side by 80, and divide this side by 80. So in this case, 80 goes into the 320, and that is going to give me 4. So I have 4 being equal to 80 goes into the 400, that is 5. So I'm going to have my 5k plus this one to the same 5, so 5k1. Now I can label this as my equation 2. So the equation 1 and equation 2, we are going to solve them simultaneously. Okay. Now the equation 1, we had 50k plus 360 k1 is equal to 133. Now equation 2, we are having 5k plus 5k1 is equal to 4. So this is our equation 1, this is our equation 2. So now the two equations, we want to solve them simultaneously. Now how do we solve them simultaneously? I can try using elimination method here. For elimination method, I have to make sure that the coefficients of one of the variables involved in the two equations are the same. So let's say I want to eliminate k. So I have to make sure that the coefficients of k in the two equations are the same. Now this side is 50 and this side is 5. For me to make sure that they are the same, I can multiply the whole of equation 2 by 10. If I do that, the coefficient of k is going to become 50. Then I can eliminate k. Okay, so multiply equation 2 by 10. So that is what I'm going to do. I'm going to multiply equation 2 by 10. So I'm going to have 10 times the 5x, 10 times 5k plus 10 times 5k1 is equal to 10 times 4. And this will give us 50k plus 50k1 is equal to 40. I can relabel this as equation 3. So in this case, I'm going to use the equation 1 and equation 3 because this equation 3 was derived from equation 2. So my equation 1 was 50k plus 360 k1 being equal to 133. This was my equation 1. So if I want to eliminate k, now that the coefficients are the same, I subtract one equation from the other. The choice is yours. The most important thing is you should follow that order. So in this case, I want to subtract equation 3 from equation 1. So my equation 1 minus equation 3. I'm doing that subtraction, so I'm going to do that correspondingly. Therefore, this 50k minus this 50k is going to give me 0. I come to this side. 360k1 minus 50k1, and that is going to give me 310k1 being equal to now 133 minus 40, and that is also going to give us 93. Now I have a linear equation involving just k1, so I can make k1 the subject. So in this case, I have to once again divide both sides by the 310, this side by the 310. I'm doing that because I want to make k1 the subject. So my k1 will be equal to my 93 over 310, in which when you simplify this further, it's going to give us 3 over 10. If my k1 is equal to 3 over 10, then I have to use this value to get the value for k as well. So what I'm going to do is I'm going to substitute k1 being equal to 3 over 10 into any of the equations above, either equation 1 or equation 2 or equation 3. Okay, so now I want to substitute this k1 into equation 2. So putting k1 being equal to 3 over 10 into equation 2. So it means that whatever that you see k1 in equation 2, substitute the value 3 over 10. And don't forget that equation 2 was 5k plus 5k1 is equal to 4. So we are going to have our 5k plus 5 multiplying the k1 becomes 3 over 10 is equal to 4. So in this case, we are going to have our 5k plus 15 over 10 is equal to 4. Now in this case, we can do some cancellation for the 15 over 10. So we are going to have our 5k plus, and this is going to give us 3 over 2 being equal to 4. So we can multiply through by the 2. And this side, we're going to get our 10k plus 3 being equal to 8. That is when you multiply this by 2, that is times 2. This one 2 times 2, and then this one times 2. And we're going to get a 10k plus 3 is equal to 8. So the next thing for you to do is to simplify this equation to get your value for your k. So we are going to have our 10k being equal to 8 minus 3. And this will give us 10k being equal to 5. You are solving for k. So in this case, your k will be equal to 5 over 10. That is, you are going to divide both sides by the 10. And this is equal to 1 over 2, which is the same as 0.5. So now we have our value for k to be equal to 1 over 2, and then k1 to be equal to 3 over 10. Now what do you do with these values, which are the constants? The next thing to do is substitute these values into the main equation, that is equation A. That is this particular equation, equation A. Substitute the value for K and K1 into this equation. So we are going to have, go to 1 over 2 and K1 to be equal to 3 over 10. We are going to substitute these two values into the main equation, that is equation A, this particular equation. So wherever that we see the K, we substitute the 1 over 2 there, and where we see the K1, we substitute the 3 over 10 there. That is what we are going to do now. So in this case, we are going to have our R to be equal to, we have 1 over 2 W plus the 3 over 10 V squared. We can simplify this further so that we get our R to be equal to 0.5 W plus 0.3 V squared. And this is the relation connecting R, W, and V squared. Or this is an expression for R in terms of W and V. Because if you look at A, the question is saying that find an expression for R in terms of W and V. All that it means is get an expression or an equation such that you get R on one side of the equal to sign, and on the other side you have your W and V. And that is exactly what we are having here. So that is the A. Now for the B, it says the resistance to the motion of a car weight 450 N moving at 40 kilometers per hour. In this case, the question wants you to find R when your W is equal to 450 and your V is equal to what? 40. And that is what the question wants us to do. So we are going to substitute the 450 representing the W and 40 representing V into this relation connecting a R, W, and V. Okay. So now when V is equal to 40 and W is equal to 450, the question wants us to find our R. So in this case, our R will be equal to, we are using this particular relation. So R will be equal to, we have our 0.5 W, and the W is what? 450 plus 0.3. We have V squared, and the V is 40, so 40 squared. So we simplify this, and we're going to get our R to be equal to 705. So you bring your unit, that is N. So that is the B. Now let's finalize this question with a C. This is a different question on its own. For the C, we are to solve 1, 3, 3 base x being equal to 4, 3 base 7. And the question wants us to solve for x. Now on the number base, in this case, what we are going to do is we try changing everything to base 10 because the bases are different. They have different bases. So let's try changing this term to base 10. Then we'll do the same thing for this one. We change them to base 10. If that is the case, then we are going to have 1 times x plus we have 3 times x plus 3 times x. So you take each digit here, you multiply that by the x. And when you are done, the exponents for the x, you start numbering them from your right to your left, starting with 0. So you're going to have your 0 here, you have your 1, you have your 2. So this will be equal to the left hand side, that is 4 times 7 plus 3 times 7. In this case, the same thing. The base, that was the 7. We try numbering its exponent starting from 0 from the right to left. So we get our 0 here, put our 1 here. Okay. Now let's try simplifying this. 1 times x squared is going to give us x squared plus 3 times x exponent 1 is going to give us 3x plus 3 times x exponent 0. X exponent 0 is going to give us 1. So 1 times 3 will give us 3. Being equal to, we have 4 times 7. And 4 times 7 is going to give us 28. So we have 28 plus 3 times 7 exponent 0. And that one too is going to give us 3 because 7 exponent 0 is 1. So 1 times 3 is going to give us 3. Okay. If you look at the equation that we are having here, it looks like quadratic equation because the highest exponent for the variable is 2. So that is quadratic equation. Therefore, you need to solve this quadratic equation. First, rearrange the terms. So we are going to have our x squared plus 3x minus 28 plus 3 minus 3 is equal to 0. So in this case, we are going to have our x squared plus 3x minus 28 being equal to 0. And how do we solve this? We can use the factorization method, we can use the general quadratic formula, or the method of completing the squares. So let's try factorizing the expression here. Okay, so we are going to have x squared, we have plus 7x minus 4x minus 28 is equal to 0. Alright, I hope you understand how we are having the 7x and then the minus 4x. Because what you have to do is, if you want to factorize it, you take the constant, which is minus 28. You use that to multiply the coefficient of the x squared, and that is positive 1, and that will give you negative 28. This negative 28, you find two numbers in which when you multiply, you get negative 28. But when you add, you get a coefficient of x, that is 3. So in this case, the two numbers that can be perfect is going to be 7 and negative 4. That is why we are having 7x and minus 4x. So you take the first two, you factorize. So x, bracket open, x plus 7. Close the bracket. Take this last two, minus 4x minus 28. The common factor there is minus 4. So minus 4, you open your bracket. X plus 7 is equal to 0. It is not going to be x minus 7, or because when the negatives comes out, whatever they are going to be left in the bracket, they are all going to be positive. So take note. So we are going to have x minus 4, x plus 7 is equal to 0. So you take each linear factor here, you equate that to 0. So x minus 4 is equal to 0, which implies that x will be equal to 4. And then x plus 7 is equal to 0. That one also implies that x will be equal to negative 7. Now the x that we are finding is a base. If you look at the question, the x is a base. And under number bases, the base shouldn't be negative. So the two values that we are having, if you want the true value for x, then x cannot be equal to negative because it's a base. So therefore, x cannot be equal to negative 7. Therefore, x is equal to 4. On that note, we end question 4 here.